Hello everybody. Today I want to continue about the star cluster. Let me share my screen. Yes. About the rest of them, as you see or pay attention to the last file that I sent and explain them, now it is the continue of that. Diffusion stellar atmosphere. We have something that it destroys the diffusion. What does destroy the diffusion in stellar atmospheres? We have two reasons. The first is convection, and the second is rotation. Rotation, about the limitation of the rotation is 100 kilometers over second, and the other is convection. As you know, and as I told you, in upper main sequence, convection is near to core, and then we have radiation. And for low mass boundary, we have the convection, and for high mass boundary, we have mass loss. As you see in the picture, you see the convection, also the convection, that they destroy the diffusion. For upper main sequence or CP stars, as I explained, CP stars means chemically peculiar stars. And in here, you see, for sun, the rotation is 2 kilometers over a second. For Earth, it is 0.4. And for Jupiter, it has 12.7 kilometers over a second. And you see, in our solar system, Jupiter has the fastest rotation in our solar system. In here, we have the rotation, the velocity for B-type stars from B0 to B9.0.5. And these numbers in the parentheses are the number of the stars. And also in here, therefore, upper main sequence of stars, that the rotation, you see how is the rotation is. They are for giants. They are for giants, and these are for B-type stars. And you see that for giants and supergiants, we have less rotation. You know, they are in the near to the rest of their life, near to the end. And in here, you see the this sinus I. For rotation, you see for A-type stars, there are more than 100 for rotation. And as I told you, for sun, that it has 2 kilometers over a second, you see that our sun rotates very, very slow than the other stars like A-type stars or B-type stars. As you see. In here, we see the rotation of A-type stars and comparison between CP stars and A0 to A1 stars and A2 to A4 type stars and CP stars. AP plus AM is for CP stars. You see that how the rotation is for CP stars in comparison with A0 to A1 stars, also for A2 to A4 stars, you see that they have very, very slow rotation than them. Also in here, we see the rotation of also A5 to F0 type stars and CP stars. This is for CP stars that are binary stars. For binary CP stars, we have more rotation than the single CP stars. And for CP stars, what makes the magnetic field? We have three theories. The first one is fossil field. We consider that we have a molecular cloud, and in molecular cloud, it rotates and it makes the magnetic field, and it spread the magnetic field to a star, for example, CP star, and then the CP star will have the magnetic field. And the second theory is stellar merger, that we consider that two CP stars merge each other. They rotate to each other and then they merge, and then we have a magnetic field. And the dynamo, what caused the activation of the dynamo is differential rotation in binary CP stars. And the third theory is contemporary dynamo. And that we say in here, what makes the dynamo activate? It is the differentially rotating radiative zones that this theory said. But these three theories have some problems. For example, for the first one, if it is said that it is only for low rotational velocities, but you know, if the molecular cloud and the star they rotate very fast, what happens? But the theory have no proof of, have nothing to say about this event. And the second one, stellar merger, it said that two CP stars merge each other. But if it happens, we have not much binary CP stars, so we should have just single CP stars. But you know, we dedicate that many known binary CP stars, that we know a lot of binary CP stars. So what can this theory say about that? And the third one said that the activation of the dynamo is related to differentially rotating radiative zones. But we didn't see any differential rotation in the CP stars, or it takes several 100 million years. So this theory cannot say anything about that. But we can see that we have just these three theories about the magnetic field in CP stars. So we should have another theory, or we should promote one or more than these three theories. And at last, we have some open questions. The first one is, are CP stars just slow rotating normal stars? The second is, are all slow rotating stars also CP stars? Or are there also fast rotating CP stars? And is there a dynamo working in magnetic CP stars? And on which time scales work the dynamo? And the last one is there a magnetic braking or not? Thank you for your attention. See you for next time. Bye.